Speak now, ever hold your peace. All right, I'm recording. All right, here it is. Here it is. We're doing the second half of this now. Take 2 of day 1. I'm trying to in the planning in the future. I'm squeezing these lessons back down a little bit smaller. I definitely bit off more than I could chew. I thought, oh, 45 minutes. I can get done twice as much stuff. No, not quite. Okay. So this is day 1, lesson 4. Right. Our learning target is I can write, interpret, and graph a straight line depreciation equation. That's what we're working on. Let me get this a little bigger since I don't have the calculator in the way. Alrighty then. We already put our name in. We already put the learning targets in. We already went over. Here's the video from yesterday's class. We did all that. We did all that. We did all that. I'm going on to example 4. I think we stopped. Oh, is this where we stopped? We wrote a straight line depreciation equation for a car purchased at $32,500, which loses all its marketable value in 15 years. Okay, we rounded the slope to the nearest hundredths. Put this equation in y equals mxb format. Okay, so we started with the coordinates, right? That's how I do, at least. I start with the coordinates. I said when the function starts, that means x is 0. If x is time, then when the function begins, x is 0. Then when the function starts, my value, my other variable going on, the value of the car, is $32,500. Got that from right there. And then I said after 15 years, the value is 0. Okay, well, if x is still the time, then 15 is years, is time in years, right? So I put the 15 right there, and the value is 0, so that's a value of 0. We use this to calculate a slope. This number right here is already the y-intercept, so we get this equation here: y equals negative $2,166.67 when we round to the nearest hundredths, plus times x plus $32,500. All right, I got something in the chat popping up. Whenever, there we go. Oh no, all right. Use, if your stuff didn't save, down at the bottom there should be a submit button. There should be a submit button, and then it'll look like, yeah, your response has been recorded. If your stuff didn't save, if you're opening this up for the first time, it looks like, then you can always use the video here to just quick, grab the answers, right? You can just go, there's the video, and if I was, watching this, I would just fast forward this over. I can even press the YouTube button, get that a little bigger, right? And then you can just fast forward. You can get those answers pretty easy without having to redo everything. All right, so I'm going to stop that. So that's the idea. So if you can just, just go through, everything's there, right? This video is kind of like our class notes as well. You still have a copy of the class notes. All right, so where was I there? Okay. Oh, and then I had you do this. I had you guys do this. This was on your own, so I will skip that one for now. Unless Desmond wants me to go over it, I'll wait for him to put it in the chat whether yes or no, whether he really wants to go over that one. I'm not seeing anything. All right, I'll talk about example 4. Maybe he'll catch me up. We'll go back. All right, example 4. Suppose that Jack purchased a car 5 years ago at a price of $27,600. According to the research on this make and model, similar cars have straight line depreciated to 0 value after 12 years. How much will this car be worth after 66 months? How much will the car be worth after 66 months? Well, that's a little trickier because we got to do some stuff, right? We got to convert the months into years to make, or at least the same units to make this work. So let's see how we're going to play this out. We're going to determine the straight line depreciation equation, right? First step is to find the slope. We're going to find the slope by looking at the 2 intercept points, right? So it's the difference in the y values minus the difference in the x values. In this case, they took 0, this 0 over here, minus 27,600, right? 0 minus 27,600. And they took the 12, we have the x values down here. 12 minus 0 is 12. So the slope is going to be equal to negative 27,600 divided by 12. All right, well, that's a bummer. Just get it from the YouTube video, copy it down. It won't take you, I wouldn't think, more than 5 minutes to get it all back if you're just zipping through the YouTube video. All right, negative 2,300. So negative 2,300 is the slope. All right, therefore, our straight line depreciation equation, right, is equal to y equals negative 2,300, right? That's the slope, times x, right? That's the variable, that's time, plus 27,600, right? Because X represents time in years, it'll be necessary for us to convert the 66 months into years by dividing by 12, right? 12 months in every year, 66 divided by 12 equals 5.5. Also, take a look at all your tabs. You might still have the your work on a tab. Sorry, I'm talking to a student in the background, sorry. All right, so 66 months divided by 12 gives us 5.5. That means 5.6, that means 66 months is the same thing as 5.5 years. Well, now that we have 66 months in years, 5.5, we can then stick. Did I send the wrong link? All right, hold on. Let's go. Yeah. Woo, I'm glad your stuff saved. The good news is here that your stuff saved. I'm going to copy this link, right, and then I'm going to post it in the chat. There's the new link for the thing that probably did save. Yes, we probably sent the wrong link. Okay, no big deal. Well, I mean, it is a slight big deal because it's confusing, but sorry about that. All right. Let me start this over again. Okay, where was I? I was on example 4, and all right, Google Forms, thanks you very much for, okay. All right, here's what we were talking about, example 4. Sorry about that, folks. All right, so here's the problem. We wanted to figure out what is the value of this thing after the value of this car after 66 months. And again, one of the problems was 66 is in months and not in years. Therefore, we need to convert it into years in order to plug it into this equation. Before we can even plug it into the equation, we need to find the slope. We find the slope by the change in y's divided by the changes in x, right? We took the y values, subtracted them from each other, divided by the x values, subtracted from each other. All right. We can stick, now that we have it converted, we can take the 5.5 and just stick it in this equation, right? Here's our equation for the line. That's our equation for this line. We stick 5.5 in, and it will spit out the value of the car, right? This is the idea of this. X is time, y is the value of the car. You stick any number in for x, and the function will spit out the value of the car for that time. It's the kind of the way to think of functions as a math machine that kind of spits out stuff. All right, so they ran the calculation, but sometimes seeing is believing. So if seeing is believing, let's just run this calculation on our calculators here. Negative 2,300 times 5.5 plus 27,600 indeed is $14,950, right? The car will be worth $14,950 after 66 months. All right, we got somebody coming on in. Let me post that. Here's the link to the assignment today is posted in the chat. There you go. We have just got done talking about example 4, and now we will play around with our new skill we just had. All right, we just learned the skills from example 4. We have a car here that sells for $18,495, and it straight line depreciates to 0 after 9 years. Write the straight line depreciation for this car. My recommendation to start is to start with the coordinate points. For whatever reason in my mind, I need those coordinate points. They help me remember what gets minus to what. Otherwise, I'll goof it up. And then, fortunately, if you goof it up, what'll happen is you'll just get a positive number instead of a negative number. But when you don't know whether it's going up or down, normally, you need to make sure you get the slope calculation right, and know whether it is a positive or a negative number. In this case, most of the examples are negative because we're talking about depreciation. Start with the coordinate point and then calculate that slope, and then you'll be able to write that equation. All right, hopefully you're done with the coordinate points at this point. So let me I'm going to do those just so you see how those work. I need a parentheses. I want 0, right? When time is 0, when the function begins, my first coordinate point, I want when the function begins, and then when the function begins, it's 0. If you can get that part right, everything else kind of falls in the line. All right, when the function begins, the car originally sells for $18,495, 996.95. There we go. All right, there's my coordinate point, right? I have a comma in between. That comma sets off the x value is the first number, comma, the second number is the y value. All right, now I have another coordinate point. My other coordinate point is when the time is 9 years. All right, so when the time is 9 years. So now if x is time, then 9 is time. 9 goes in the x position in the coordinate point. And then, of course, the value at the end of this function, it depreciates totally to zero, right? So I have to put a 0 here. All right, those are my coordinate points. Now it should be pretty easy to calculate the slope. Go ahead and calculate that slope. You can use the problem above to help you remember what the slope formula is. If you're putting this in your calculator using kind of a straight line, you're going to need parentheses for the top, for the numerator and the denominator. Right? A divisor line has implied parentheses. All right, for those of you who are one-lining it, like I am oftentimes, right? I'm going to take this y value over here. All right, I'm going to subtract the y value on the other end, minus 0. And then I'm going to divide by, parentheses, the x value over here. I started with this number, so I got to start with the x value associated with it. 0 minus 9. Ooh, minus 9. There we go. And this the calculator can help us with. There's two ways to do this in the calculator. Here's my, honestly, Mr. Salt, that's the way I do it. I don't know why I do it this way. I'm an old fuddy-duddy. Like I do it like this. I use the parentheses, I do the divide, I do the parentheses, and I divide by 9. All right, and that's how I get her done. Mr. K might suggest to you, you can press like alpha, y equals, right? The green alpha button, the y equals button, gives you this little menu here. This little n over d is numerator, denominator. And then you can just kind of put your numbers in without the parentheses. So I don't know if you like that more. If you like that more, go for it. Mr. K's giving me the thumbs up. He likes that more. He likes that way better because it looks just like it does over here, right? It looks just like it. That way, we just keep things together. Either way, same number, same number. So I don't know. I grew up before graphing calculators. That's when I learned all this stuff. There were no graphing calculators. I did my tables by hand. So I still use the straight line method. I had a scientific calculator. That was it. Okay, so what was my answer even? All righty, here we go. So I have a slope of negative 2,055. Okay, now we still aren't done. We still aren't done. In fact, you didn't actually need a lot of the stuff we've already written. I'm just putting it there so you can know how I'm thinking through this and how to do this step by step. I'm now going to give you a second to write the equation. It should be pretty easy at this point. It should have the format y equals m times x plus b. Or if we're using our calculator, sometimes we might call it a times x plus b. I'm not a fan of the calculator calling it a, but again, that's because I'm an old fuddy-duddy and I like things the way they were. At least when it comes to calculators. Okay, I'm hoping that you know that at a or m, whichever one you want to call it, is equal to the slope. And the slope is the thing we just calculated. So instead of m, I need to get rid of the m or the a and put negative 2,055. That's what I need there. It needs to be multiplied by x. That's very important. A common mistake is that students will forget to put the x in there. That x here creates a variability that affects the y value over here. So this x and this y, they're connected. Once we get these written out in an equation, these two things are connected. As x changes, y is changing, right? In a defined function, which is what this equation is all about. The equation defines how y is changing in relation to x. B is the y-intercept. That one, I don't know if that's harder for you or not. that's actually where the function starts. And the function started right there at 18,495. So if I wanted to go back here, I would say 18,495. That's the equation. That's the only thing you actually needed. That's the only part of this you actually needed, was y equals negative 2,055 times x plus 18,495. That's the equation. Everything else was just the work to get there, step by step how to get there. All right. All right. So I'm gonna let me see. Oh, now we're gonna take the same problem and we're going to find the value of the car after 81 months. Okay, so do yourself a favor, just grab what your answer that you had here, the y equals the equation, stick it in here, and now you can use that to run your calculation. That might help you. I don't know, it would help me. Go ahead and try to calculate what is the value of the car after 81 months. How would you do that? Use example 4 as your model. Example 4 goes exactly and shows you exactly how to do this kind of thing. All right, so remember, the issue here is that 81 months is not the same unit of time as 9 years. So our first step is to convert 81 months into years. And how do they do that? Remember, they divided by 12. They took the months, they divided by 12 to find years. So that's what we're going to do over here. We take 81 months, calculator go back on, 81 divided by 12, turn it into years. This is 6.75 years. 81 months is the same thing as 6.75 years. Well, if that's the case and x is time, then I can stick 6.75 in for x, right? I can stick 6.75 in for x in this equation and then figure out what the heck that equals. Let me let the math machine tell me. All right. Negative 2,055 times 6.75 plus 18,495, 4,625. Oh, sorry, $4,623.75. All right, that's the idea there. That's what we're looking for. The value of the car after 81 months will be $4,623.75. You may or may not want a dollar sign. That's up to you. Sorry about coughing at you. I forgot to mute that time. Okay. Nothing like coughing right into a microphone, right? All right, I'll give you a second to get that down, and we'll start with example 5. All right, it's also on my calculator if you need it. Example 5, the straight line depreciation equation for a car is y equals negative 4,000 times x plus 32,000. Let me just step back for a second. Let's interpret what this means. What is this saying? It's saying we have a slope of negative 4,000. It's saying we have a y-intercept of 32,000, which means every time x increases, we're going down by 4,000 in value, right? For every year that x increases, we're going down 4,000 in value, and we are starting with a car that starts at a value of $32,000. That's what this equation is saying. This is kind of how you read it and say it in English. For each additional year, the car's value drops by 4,000, starting at a value of 32,000. That's how I would actually write this out as a sentence. Okay. In approximately how many years will the car's value decrease by 25%? Okay, decrease by 25%, not decrease to 25%. Okay, that's important to read those little, I don't even know, I don't even know what to call these. Mr. K, you know what to call by? Is that an adverb? Is that I don't even know what the grammatical piece or technical name for these kinds of words are, but
What, for the or?
by, the word by, by.
Decrease, no,
By 25%.
yeah, I don't know.
It's like isn't it an adverb? It's like for, between, in, with. It's one of those words, by. Anyway.
Yeah, it kind of is.
I forget what the English term for that is. Someone help me out. Google it. I always want to know these things. All right, solution. Here's how we're going to figure this out. The original value of the car is the y-intercept, 32,000. You must determine the actual value of the car after it has dropped by 25%. And this can be done two ways. First way, you can find 25% of the original value of the car and then subtract that amount from the original value, right? This is how we've done it in class so far. We take 25%, we divide it by 100, we get 0.25, we multiply that by 32,000, we find that that's 8,000. So 25% of 32,000 is $8,000. Well, now that we know that 25% of 32,000 is 8,000, we take the 32,000, subtract the 8,000, and we get 24,000, right? The value that is 25% less than 32,000 is 24,000. Woo! Right? That's the way we've been doing it. There's an easier way. This is probably the way Mr. K does it. This is actually the way I do it, actually. So I wouldn't do all this. I would do it this way, much easier, one and done. I would say, well, I know that 25% minus 100% is 75%. So what I'm really trying to find here is what is 75% of the original value. That's 100% minus 25%, right? So I would take 75, convert that into a decimal in my head. And I would take 0.75, multiply that by 32. And I'd find that 75% of 32,000 is 24,000. You know, that to me is a little bit more straightforward. I like it better. Do whatever you feel comfortable with. It's honestly, it's up to you. Okay. So we're trying to determine the length of time. So we're going to solve the depreciation equation for X. Okay. So, let's see, what are we doing here? I'm trying to figure out what they are trying to solve. Oh, so we're trying to find when the value of the car is going to equal 24,000. So here's our equation. We're going to stick the number we found. We're going to stick that 24,000. That's 75% of the value. We're going to stick that in our equation for y, right? Because y is the value over time. Yeah. And now we got to solve for x. We need to figure out what would the value of x be if the value of y is 24,000, right? Just like you can stick a number in for x and it'll spit out a value of the car for y. It goes in reverse too. We could stick in a value for y and get it to spit out an x value, kind of in reverse. So here we go. We're going to first subtract 32,000 from both sides. That gets us negative 8,000 on one side, and then negative 4,000 times x on the other. Then we divide by negative 4,000 on each side of the equation. We find that x equals 2. The car will depreciate by 25% after 2 años. Okay? All right. From example 5, in approximately how many years will the car's value decrease by 67%? All right. I'm just going to give you a few seconds to think about this one. Let me just kind of work. I'm going to work this one out, and I'm going to have you do the next one. Okay. So I just wanted you to think about it, and now I'm going to do this one. Okay. So my first step is to find out what is me. I want to take 100% minus 67%. That's my first step, because I want to know what I'm actually looking for. 100 minus 67. Okay, 33. So I'm really looking for 33%. I want to know when the car's value reaches 33%. Sorry. Okay. The car starts at a value of $32,000, right? $32,000. So I want to find out now, what is 33% of $32,000? I think I said, yeah, there we go. I want to find out what 33% of 32,000 is. Well, of course, I'm going to have to, take the percentage, convert it into a decimal. I do that by dividing by 100. I can kind of do that in my head just by moving the decimal place over by 2. So I'm looking at what is 0.33 times 32,000. So let me try to do that. 0.33 33% of $32,000. Okay, that's 10,560. 10,560. That is the value of the car when it has a decrease by 67%. When it decreases by 67%, this is the value of the car. So now what am I going to do? I'm going to stick that in for Y, right? Our Y values are how much the car is worth over time. So I need to solve for this equation here. 10,560 equals, that's going to be my Y, negative 4,000. I'm going to use the same equation I used over here, negative 4,000 times X plus 32,000. Now I just need to solve for X in this equation. For me, some of you might like to do this on paper. If you like to do this on paper, I recommend that. For me, I think I can pretty much do it on the calculator as long as I can see the equation. So I need to move it around. I need to move this around. There we go. And I need to put a semicolon in there to break it up. There we go. Okay, now that I can see the equation when I click off it, I can just look at this and say, okay, my first step is going to be I'm going to minus 32,000. So I'm really going to keep track of this side over here. I'm going to start with 10,560. I'm going to minus 32,000, minus 32,000. And I just kind of keep in my head, now that I've minus 32,000 to both sides of the equation, this gets canceled. So now I'm going to ignore the 32,000. I got rid of it by subtracting 32,000 on both sides of the equation. I now have negative 21,440 on the left side of my equation. Now I only have negative 4,000 times X on the right side of my equation, kind of like doing all this in my head and with the help of the calculator a lot. And I'm now going to divide by negative 4,000 on both sides. Well, that just cancels the negative 4,000 on that side. So I'm dividing by negative 4,000. And I get 5.36. 5.36. All right. So X equals 5.36 semicolon. So that's the answer. That is the amount of time. That's the number of years it will take for this car's value to decrease by 67%. I just feel like I also want to do this the old-fashioned way, just so you remember how to do this the old-fashioned way. I don't know why. Maybe you guys don't like the old-fashioned way as much, and then there's no point in this, but I feel like I just want to make sure we know what we're doing here. 10,560 equals negative 4,000. Oh, I need to write smaller. I'm going to fit it in there. Times X plus 32,000. Oh, just barely got it. All right. I'm subtracting 32,000 over here, which gets rid of this. Subtracting 32,000 over here, which gave me negative 21,440 equals negative 4,000. Probably should have used I have the tablet that helps me do this a lot better if I would have used it, right? And then I'm dividing by negative 4,000. I showed you how to do it in the calculator just so, because that's how I do it. This cancels, which gives me X equals whatever this is over here. And then we found that was going to be 5.36. All right, that's kind of how you do it on paper. That's the old school method. That's Algebra 1 stuff. Just wanted to have you realize that that's kind of how it goes. Okay, so now I'm going to have you do this one. From example 5, how many months? Oh, I'm going to ask you how many months it's going to take for the car's value to decrease by 50%. So keep everything in years, convert to months at the end. All right, I have baked potatoes in the oven, which are done. So as you're working on this, I want to go get those. Baked potatoes tonight for dinner with some broccoli, cauliflower, and pine nuts. A little garlic sauce too. All right, how are we doing? Anybody need this? Do you need me to show you this one? Or can I move on? This is time for you to speak up. Tell me what's going on. How about this? Since you guys like the participants, give me a green check mark for I'm good, or give me a red stop or no for no, I need help. I need to see this. Show me this one. I'm not sure how to do this 50% thing and figure out the time in months. Desmond, Javier, let me know how it's going. Give me an indication in the chat or in participants how you're doing. Okay, I'm not hearing from anybody. All right, hopefully I'm not losing you. All right, the next one is write an algebraic expression. Oh my gosh, I can't believe I did this to you. I'm just mean. I'm cruel. Okay, we're going to do this algebraically. Let's do this. Okay, have the value of $D. So D, right? D is the number, the value of the car that we want to find out. It's what is the slope here? The slope is negative 4,000. Sorry, I should have remembered that one. That's an easy one to remember. Negative 4,000 plus 32,000. Here's what I want. What I'm asking you to do here. You actually, this works. You could leave it just like that. Actually, I didn't tell you to put it in terms of X, did I? But what I think that I was looking for was I wanted you to take D and subtract 32,000 from both sides in your head, right? And then put that in parentheses and then divide by negative 4,000, just like we've been doing, and say, hey, that's equal to X. And I was looking for an equation where you set this expression equal to the time, right? But I don't think I actually stated that in the question, so I could accept either one of these responses would be fine. Either one of these responses would be fine. All right. Example 5. This should be the last example. Please tell me it's the last example. I think so. Yes, we're almost done with this thing, people. We are almost done. Okay. Woof. Anybody else tired? I'm tired. All right. Example 5. Example 5. The straight line depreciation equation for a car is y equals, okay, we have the same thing as we had before. Negative 4,000 times x plus $32,000, right? In approximately how many years will the car, wait, did we just do this? We just did this. How come I have this twice? Oh, because I'm going to talk about, all right, we already did this part. Good. Now I'm going to talk about expense functions. All right, so here's a graph. This graph, the red line is the depreciation function, right? This is the car's value over time. That's the red line. As time increases, as the x value increases, the y value decreases. That's why this line is going down. This is a depreciation. The value is going down over time. The blue button is the expense function. This expense function is going up over time. The expense function can be a lot of different things, but in a lot of cases, in this case, I think the expense function is how much is being paid per month for the car, right? So when you first start this function off, you paid like $4,000, it looks like, or maybe $5,000 as a down payment for the car. After, these are months, after 20 months, you've paid a total of $15,000 on your car, and your car is still worth $24,000. After sometime like 30 months, you have paid $22,000 about towards your car, and your car is worth about $25,000. The thing of it is there's a point at which you've paid more for your car than your car is worth, or actually when these two things are equal, and you've paid the same amount for your car that your car is actually worth. And then beyond this point, you start paying more money for your car than your car is actually worth. All right. I'm sure you're glad to know this about life, that eventually you'll pay more for things than they're actually worth. It's great. It's called being upside down. Okay. So we're going to determine an appropriate graphing window. Let me see. I think I just wanted to show you what this is. And I wanted you to be able to start answering some questions about like systems of equation type stuff without us getting in too deep into it. So expense functions. You can create an expense function for an automobile. While there are many expenses that contribute to running and upkeep of a car, for the purposes here, the expense function is composed of a fixed expense down payment that you make when you purchase the car and the variable expense monthly payment that you make to the lending institution. Looking at the linear expense and depreciation functions simultaneously give you insight into the value of your automotive investment. I'm going to ask you a question of how might the expense function be altered so that it reflects a more accurate amount spent over time, and what might the effect this might have on the graph. So I have a question like, think of if this blue line is only how much you paid for a down payment and how much you're paying every month, what other ways could we maybe make this more accurate? Like what other variables, expenses do you have with the ownership of a vehicle that perhaps also could be included in an expense function? Think about all the different like costs associated with owning an automobile. And what effect might additional costs have on the graph? Okay, well, it's going to increase the slope. Additional costs are going to change the overall rate of the average rate of change. So it's going to increase the slope, which means these two lines are going to meet sooner. So somewhere up on the line, somewhere the blue line will intersect. The blue line will get steeper as its slope increases. All right. We have a little bit less than 10 minutes left. I am going to let it go there. All right, complete the learning target questions, complete your effort, and then click the submit button. The submit button is very important. Also, don't forget to don't leave any blanks for feedback either. Blanks only give you half credit. You got to at least write nope or something to get some credit there. So then you click the submit button. Click that submit button. That saves your work. All right, that's very important. And then you can wish us a happy Tuesday. All right. I'm going to stop the recording.